Uh, I know we're coming up to a holiday, so we're going to kind of miss you, but we got some good shows coming up. And tonight we have Kevin Boucher on talking about AI in astro imaging. And I'm probably not the only one that's been deluged with everything AI. I mean, there isn't a promotion I get that they don't say, well, it's better because of AI. But in fact, mostly I just block those people. But for our hobby, AI has really made a difference. So Kevin's going to tell us about that tonight. And next week we have Timothy Martin. And before I go over our revised schedule, Tim, you want to give us a kind of an elevator pitch on what you're going to talk about?
Sure. So I'm going to talk about automating your scopes at a remote observatory with Nina and using the sequencer power-ups plugin and some other plugins, but mainly the sequencer power-ups plugin that Mark Blank has written and refined over the last year or so. I've worked with him quite a bit on that, on getting it refined and dealing with edge cases. And so really the goals are to show how to manage the nightly imaging process, start imaging at the right time, stop imaging at the right time, handle roof closures during the night, handle edge cases like when the roof opens and closes several times in just a few minutes. Those are kind of difficult cases because you might be in the middle of slewing or you're in the middle of an autofocus or something like that. And then also providing more advanced real-time messaging, like to your phone or to your tablet device or some other device, and then automation of calibration frames. So if you shoot multiple targets at multiple rotations and you're a real stickler about having flats for every rotation, then there's a way to automate that as well. And so you can go to bed and sleep well. It's probably not as advanced as what some people do with ACP and just dumping targets into a bucket and waiting for them to, waiting for the telescope to do it itself. But it is a huge step forward.
I don't know. I think that we'll probably all agree that Nina in the last couple of years has really become a powerful automation capture software. And in fact, I think if anyone is looking to purchase a new system and hasn't invested in another one like ACP, probably Nina is first on their list.
Yeah. Well, I can tell you that I was a software developer for many years, and then a CTO for many years, and I think Nina is the best software I've ever seen or used ever of any kind. The UI.
100% agree. 1000% agree.
The UI is flexible and intuitive.
And we have a bunch of head nods here. So we're all looking forward to your presentation next week. And our calendar, we had a discussion before the show started. So in the next month, it's kind of filling up. Tim's going to be next week. The week after, we have Labor Day. So sorry, guys, we won't be here. Enjoy your holiday. Molly's going to give a presentation on star parties. Jaime after that on fast processing on PixInsight. We have Daryl Mooney after that. I'm going to give a presentation on HORGB. And after that, after we have Rods, he's next, we have some open dates. So we do encourage any of you out there that has an idea for a show and would like to propose it, just go to our website, theastroimagingchannel.org, go to the contact form and just send us notes. Someone will get back to you, and the odds are you'll be on the show sometime in the future. And I think that's all for our introduction. And now we're going to hear from Kevin on the wonders of AR and astrophotography. Kevin.
All right.
Go for it.
Let me share my screen here. All right. And I'll bring up my presentation. All right. Can you guys see this fine?
Yep, yeah. There we go.
Okay, great. So my presentation tonight is as much about AI to a certain degree, but it's really more about injecting AI into a workflow And so that's kind of, it's kind of an all-encompassing thing. Talk a little bit about AI and how it really integrates with my workflow. And it's really made some major positive changes in my workflow. You can see this is my little setup down here, my backyard observatory, little roll-off roof setup. So let's get started. A little bit about my background. I am the founding member of Aldrich Astronomical Society, the imaging group. Aldrich has been around for a long time, since 1932, and it's just a local astronomy club. And I started the imaging group about 15 years ago because we didn't really have anything going at the time. So I currently am on the board, one of the IT guys. I'm also in charge of membership. So, guy in charge of the website, basically. Molly probably knows something about that.
Kevin, could I interrupt you for a second?
Sure.
Are you guys seeing Kevin still live, or are you seeing his slides? I am seeing.
I think he's working on it because Tim left the meeting, so that's going to shuffle the faces. So Jaime might be doing some rearranging of the faces.
In other words, we're not seeing the slides that we should be seeing.
Oh, okay.
I see the slides. Okay, we've got his face back up on the. It looks good.
We're seeing the slides. We just didn't have Kevin's visage in front of us.
Yeah.
So are we okay to proceed, or?
Yes.
Okay.
Wait a minute. I am still seeing Eric. He just interrupted, and remember, we're 30 seconds ahead.
Yeah,
So I am not seeing the slides on YouTube.
Okay, I am, and if you hit refresh and drag the slider all the way to the right, then you'll be a little more caught up.
Okay.
We're up to date on YouTube.
Thank you.
Okay. So I've been trying to improve my astrophotography skill set for 25 years now. I started with a Meade DSI way back in the day, actually with a DSLR a little bit before that. So, and I've been retired 10 years now from a 30+ year career in software consulting. So I'm an IT guy anyways. In terms of my equipment, I showed you a picture of my observatory. I have an Astrophysics 900 GTO mount that I purchased used. Best decision I ever made in my life. It's probably going on 15 years old now, and it just runs like perfect. It never ever. So if you ever in question of a mount, go for a good one. My primary imaging scope is a GSO 10-inch carbon fiber Ritchie-Chrétien, which I like a lot. Had to do some modifications to it, but I do like it a lot. I use a Astrophysics CCD T67 telecompressor. So it takes my GSO 10 down to f6 and 1500 millimeter focal length. So that's primarily where I shoot from. My focuser is a Moonlight with a high resolution stepper, and I like that a lot. It's working very well for me. And my secondary guiding, and also I swap my imaging camera around with the scope. It's a William Optics 81 GT refractor, which is, you can see sitting on top of my primary scope there in the background. I have the very popular ZWO ASI 2600 mm. I love that sensor regardless of who manufactures the camera. It's just one of the game-changing cameras that I've worked with. And I use the ZWO 7-position filter wheel with it. So this will be a mono presentation. We'll talk a little bit about that in a bit, but it does translate very well to color, I think, too. My guide camera is a Starlight Express Lodestar X2. Now, that's my setup for hardware. My software, we've been talking about Nina a little bit. I am a major Nina fan. I use it for my acquisition and automation. I do not have a motorized roof for cloud sensors, that kind of stuff, but pretty much everything else I use it for. Start it, early evening and let it run all night long and park the scope. And I just go out there in the morning and basically shut everything down. So love it. And I do pretty much all my image processing in PixInsight. I have gone through, using Photoshop and GIMP and, a lot of other software over the years. And I'm pretty much exclusively using PixInsight, especially with a lot of the new scripts that are out now. So, so this is a mono workflow discussion. but it can be applied to one shot color. And I'm going to talk a little bit about that a little bit later. So the AI tools that we're going to discuss tonight that have helped with my success are, in order of release from RC Astro, is Star Exterminator, Noise Exterminator, Blur Exterminator, Graxpert, which you can use for both gradient removal and noise reduction. And what's great about Graxpert is it doesn't have to be a PI tool, but PixInsight tool. You can basically use it as a standalone. So for people that are not using PixInsight, do not have to use one of these RC Astro tools in order to get an AI tool for gradient removal and noise reduction, which is a nice thing. But of course, Graxpert does run within PixInsight also, and it's free. StarNet V2, I'm going to touch on that. Really kind of competes with Star Terminator, or Exterminator, should I say. Deep SNR, I'm going to talk a little bit about Deep SNR. There's been a lot of reviews on YouTube of late on this product here. This is also written by the gentleman that wrote StarNet. So he's into noise reduction too. And there's some interesting reviews on this. And I'm going to very, very briefly touch on Skywave Collimator, which is an AI tool from Innovation Foresight for collimation. And the only reason I'm going to touch on this extremely briefly, because it's not really in my workflows, it did factor very much into the quality of my photos in terms of trying to get really accurate collimation with my on my RC. So that's pretty much it. So to get into more detail on some of these, we'll start with Star Exterminator. So I find this is the AI with the single biggest impact to my overall workflow. And what I mean by that is in terms of modifying my workflow, and you're going to see that when I get into the workflow itself. Primarily because I am separating the DSO from the stars, and I am processing them differently. I'm stretching them differently. I'm not sharpening the stars where I am the DSO. So forth and so on. So it really did modify how I'm really processing my image. I'm stretching my DSO only image to maximize the detail in the fainter areas without blowing out the brighter regions. And I do that personally using GHS. But I'll throw a call out to, for a more simplistic tool for stretching to Frank at SETI Astro. His statistical stretch, I find, works very well if you want something much simpler. A great way to correct background artifacts on your DSO only image before recombining with the stars. So I used to have a lot of off-field bright stars that would cause, on-sensor artifacts on my images before I fixed the problem, because I managed to trace the issue down. But before I could do that, I was fixing these background artifacts, when I had a DSO and background only image without the stars in it. It makes so much easier in order to, to correct those images. So I'm going to touch on that. I stretched the luminance stars only image to control both the number of stars and their intensity. So you don't have need for that, all those star reduction routines. And I'm sure, a lot of you have used, the morphological transformations and PixInsight, the various scripts that have been out there, both from PixInsight and from other people. And honestly, this is just so much better way to do it. In terms of just stretching it. Maybe you may want to remove some of the background smaller stars using MLT or something, but it's a great time to be able to control what you want, the number of stars you have and how bright and how big they are. I like to use ArcSign's stretch algorithm in GHS to stretch the color stars only image, primarily because I find it optimizes the color in the stars without burning them out. I really like colorful stars. Maybe some people think that they look a little too cartoonish. Personally, I like to see the color in the stars myself. That's my personal preference. And then I sharpen the luminance and the narrowband DSO only images, but not the stars. So it's nice you have that ability because they're all separated out from each other. So we're going to cover that in a lot of detail in the workflow itself. And finally, I find overall that Star Exterminator works better than the alternative removal process, StarNet V2, StarNet++, whatever you want to call it. but StarNet does a good job. I just think Star Exterminator does a little better job, just in my opinion. But it is a tool you have to pay for, whereas StarNet you can get for free. So I'm not sure how well some of these slides are going to translate in the the video compression, but this you should be able to see easy enough. For those of you that have not worked with any of these tools to separate the take your image in a linear state and separate the DSO from your stars, this is basically what it does. You can see on the right side here we have the stars only image. On the left side we have the DSO with the background of your image. Okay, so in terms of noise exterminator, I found it much easier than the previous techniques I used to use, primarily using multi-scale linear transformation in PixInsight, combined with some masks, so I could protect maybe some of the fine detail in my, let's say, nebula or galaxy or whatever, because it tended to blur some of that fine detail. So the trial and error thing is pretty much gone using those kind of tools with noise exterminator. So all these previous techniques I've tried tended to blur not only the noise layers, but some of the fine details, in the really small wavelet layers, where the noise exists. Noise exterminator preserves the fine details, which is obviously what we want. And so here's an example. Once again, I'm not sure if you're going to be able to see this. I really tried to blow up an image, a section of an image a lot to show what originally the noise looked like in the image, and then what it looks like after applying noise exterminator. So you can see that it really does a nice job. Now, I personally try not to make it, I like to leave a little bit of grain in there, very fine grain. Otherwise, I think it looks plastic if you try to go too far with noise exterminator, which you can do. And I like to play with the sharpening part of noise exterminator so that I try to preserve as much detail as possible. And if I start to see even the slightest amount of ringing around the stars, I back that off considerably. So that's kind of how I kind of find that balance between the amount of noise reduction I'm doing and the amount of detail I'm trying to bring in and not lose in the fine detail of whatever my DSO is. Now, in terms of deep SNR, this is a relatively new tool. I don't use it personally. I have played with it a little bit. What I like about it is, it's got a very simple control. As you can see here, it does run in PixInsight as a process. It has a simple slider, which controls the strength of the noise reduction. And it has a checkbox specifying whether you're playing with linear data or not. That's really it. It does a very good job, but there's some pretty big gotchas with this tool at the current time. One is, he doesn't have any repository to work with. So you got to kind of manually kind of go through the process of loading this tool into the execute directory of PixInsight, the bin directory, and then basically manually load it into PixInsight as a process. And the problem with that is, of course, every time you get an update from PixInsight, it's going to whack that and it's going to be bye-bye. So that's one big thing for me. I guess I'm just lazy, but I just don't want to deal with that reloading this every single time. The other thing is, right now it's only trained on color images and not monochrome images. So I do know that, at least on the website and from some of the blogs I've read, he is working on the mono capable version of the AI. It's just not ready yet. I don't know if any of you have seen Queeve the Lazy Geek. He's got a YouTube video that he's put out recently on this tool, and he found some pretty interesting things about this, where he actually found that some of the AI was actually creating stars from some of the background noise, which I found interesting. So it's a little troublesome in that he's thinking that on his test, it's actually creating data that's not there, which is a little scary. And that's something you got to watch out for with an AI tool, of course. So I'm going to, this is not an AI thing at all. It's on the RC Astro website, but it did factor very much into the resolution of my images that I'm working with now. primarily in helping me determine what the best sampling rate I should go for my imagery. Because, you know, I've always worked under the premise that probably a lot of you have, that I should be shooting between, you know, that magic 1 and 2 arc seconds a pixel in order to, you know, not be troubled with the seeing issues and all that kind of stuff. And honestly, you know, I played with this tool on Russell Croman's website, and I loaded it. As you can see, I loaded in all my parameters. This white box that's here is, in essence, a blow up of the top part of the screen that you can work with, and you basically either load in your aperture and focal ratio or your focal length and focal ratio for your setup, along with things like the seeing conditions, your wavelength that you want to, you know, test or analyze. I just left it at the green wavelength in the middle. Honestly, I didn't think that slider made any difference anyways. My pixel size for my camera, the sensor size, which I don't really think makes a lot of difference anyways. And I tested it with various binning levels and drizzle levels for that matter to see what would be the optimum. And what I found interesting is, if you look at the results of the analysis of not binning, it's basically telling me, as you would guess, that my resolution is 0.52 arc seconds a pixel, which sounds like you're really oversampling. And what I found interesting in Russ's analysis here is that if you look at the colors at the bottom of this little frame here, it will color any of these analysis figures as red if you're undersampled and orange if you're excessively oversampled. And none of this is colored. So I found that a little interesting. So for the heck of it, what I did is I put in, you know, the typical type of binning that I would normally do with my setup, which is 2x2, which would give me a 1.03 arc second a pixel resolution. And if I did that, you can see down below, it said that I was undersampling if I did a 2x2. And needless to say, if I did 3x3, which gives us dead center of the recommended range of 1.55 arc seconds a pixel, I'm even more, you know, undersampling as far as Russ's function was telling me. So for the heck of it, what I did is I tried it at basically sticking with the, you know, basically no binning whatsoever to see what I would get, combined with using blur exterminator, which is what we're going to talk about next. Okay, so you can see on the previous slides, you know, the analysis results basically said that I should not be sticking with the tried and true sampling rates. I should go with, you know, basically no binning whatsoever on my setup, which is what I tried doing. If you factor in blur exterminator to deconvolve your images to account for seeing, the effects of seeing, and I have roughly 2 arc second seeing conditions where I shoot from here in Massachusetts, you're getting close, you know, with using this tool to getting closer to that diffraction limit maximum of what your optical setup can handle, you know, depending on how much noise you're getting in your images. And frankly, I wasn't getting much noise with that camera. So is oversampling, you know, here's a question, is oversampling to a degree such a bad thing? I mean, I used to think it was a bad thing in that it used to bloat my stars out, even though I was getting maybe better resolution on the DSO. But now with products like blur exterminator, is it such a bad thing? Because you can really knock those stars down. And with the workflow that I'm using, I can actually control my star size a lot anyways. And maybe, and according to Russ, we should probably always be drizzling. So I tried all of this. And on that subject of drizzling, I think Molly's put this particular URL at the bottom. In talking with Russ, he recommended that I read this article, which I did, and I found it fascinating. You know, and that drizzle plus deconvolution is a killer combination. So in terms of getting to that really maximum possible resolution in your pictures. So that brings in, very briefly, skywave collimator, because—
Excuse me, Kevin?
Yes.
Kevin, before we go on, I have a personal question, and I wanted to remind everybody to put their questions over in the chats. If you have any questions, we haven't from anybody else. But the comments you made about binning just now in an LRGB setup, would you say that the best sampling you should get would be to have all of them unbinned, binning one by one, or the more traditional luminance is one by one and the R, G, and B are 2 by 2?
I do everything one by one now. But you know what? It's perfectly fine if you want to go with 2 by 2 on your chrominance, because in the end, the luminance picture is your scaffolding basically for your whole picture. So what I mean by that obviously is you can think of the colors just paint by numbers into your luminance picture, and that's where all the detail is. So yes, Alex, you could very much stick with going one by one on your luminance and going 2 by 2 on your color. That would be perfectly fine.
It just seems to save time because you can gather more light with the 2 by 2 in the chrominances.
Right.
Okay. And there are no new questions here, so let's just continue.
Okay. So the only reason I wanted to bring this in, this Skywave collimator, is because it did factor in heavily to the quality of my imagery in it, along with this other stuff I'm talking about, obviously. So shout out to Innovation Foresight. This is basically an AI tool that basically does a point spread function analysis on your defocus stars. And I found it to be, you're not using any lasers here whatsoever. The whole idea of this product is that you try and, if you could see in this target area here, you can see there's a circle with a dot in it. And you're trying to basically, based on your collimation screw adjustments, to get that circle into the green area of this target, okay? And so in the case of an RC, you've got to actually work 2 mirrors. And so it's designed to work with all different types of telescopes, including refractors. And I found it did an amazing job on collimation. And I've tried a lot of different tools over the years, primarily laser collimation tools, but I found this to do a superior job. So just a quick thing, and that's all I want to mention on it because it factored in heavily, and it is an AI tool in the quality of my images. So, so let's move on here. So Blur Exterminator is one of the last RC tools we're going to talk about. So this is a deconvolution tool, not a sharpening tool. So it allows you to optimize your resolution to basically rebuild that detail that you're losing as a result of seeing issues, okay, for primarily seeing, but obviously it could be partly your optics too, but it's not, I hear a lot of people say this is like a sharpening tool. It kind of looks like it's sharpening, but it's really rebuilding, okay? I think this is the AI with the single biggest impact to the fine resolution in my images now, in addition to obviously getting the optics right, and using a proper bending level. So it's very easy to use compared to the very many iterations I used to use. I don't know if any of you have played with the PixInsight deconvolution process. Oh my God. I must have spent hours playing with the settings to get rid of the worms and the panda eyes and to try to actually get a good result. And this makes it so much easier. I absolutely haven't seen any ringing of stars or worms or anything like that, like we used to get with the deconvolution process. And what another nice sidebar of this product is, not only does it minimize that star blow if you're maybe oversampling a little bit, but it also goes to correcting star shapes due to guiding issues or optical aberrations, like on the edge of your images for people that are, using not well-corrected refractors or whatever. So it does a great job of actually correcting the stars. You don't have to crop that stuff out anymore like you used to. Once again, I'm sure the resolution of the video is not going to be quite good enough for you to be able to see the difference here before and after, but there is a massive difference before and after using Blur Exterminator on the fine details of this nebula. And you really can see it on the luminance in narrowband frames. So we'll talk a little bit about Graxpert, another AI tool. This one is free.
Kevin,
Yes,
Before you get to Graxpert, so do you do star exterminator and then blur exterminator?
I do blur exterminator first. And we're going to get into that in the workflow in a second, Alex. I mean, Eric. So I'm going to cover
Rather
that.
than removing stars, because
Yeah,
it functions differently if you have a starless image versus if you have stars in it.
exactly. Yeah, definitely. And I'm going to show you that my process. I actually am using the process that, the workflow in terms of Russell's 3 tools in the way he recommends using them. I use basically blur exterminator, noise exterminator, then star exterminator in that order.
Okay, thank you.
You're welcome. So you can see this has got its own user interface that you can opt to use if you want. And you can also see that you have the ability of doing background extraction or denoising with this tool. So what's nice about this tool is if you're not a PixInsight person, this is a great tool that you can play with to not only correct your backgrounds, but basically do some really good denoising. Of course, Graxpert also comes with a process that basically calls that same program in the background, pretty much. But so you can basically run Graxpert from within PixInsight if you want to. I personally don't use this tool because I find that noise exterminator does at least as good a job as Graxpert does in the noise reduction, but that's my personal preference. In terms of background correction, I'm going to talk a little bit more about that in a bit. So I don't know if there's any questions, because I am going to start talking about my current workflow. So is there any questions that we want to address before I get into that?
No, there's a couple of comments, but there are no questions directly.
Okay, great. So we'll get right into it. So as I'm sure a lot of you, I start out with using WBPP basically to do the calibration, registration, normalization, integration of my masters for all my light frames, or regardless of what type they are. I like to use image integration, if not narrowband, for creating a synthetic luminance, although you can use it for combining your narrowband images. I have done that also, but I really do it for creating a synthetic lumen from RGB. And the reason why I do that is for actually a couple of reasons. And up here in New England, we don't have a ton of great, image capture nights up here for me to be wasting any time basically taking purely luminance frames. So I like to use that time to capture, more RGB, more narrowband, whatever. Okay. The other reason is I look at the wavelength, the pass bands for both, the RGB filters, and if you compare it to, what you're bringing in with a luminance filter, basically. You're bringing in a lot of potential light pollution. You can compare, a lot of these new filters that are being used now for especially the dual band, tri-band, and quad band filters that are being produced for, for color cameras. You'll see that the pass bands that they generally are basically blocking are included, and it's for reasons of basically light pollution that they're trying to, save you from. A lot of that is being included in these luminance filters. So it's another reason why I find that when I create a synthetic luminance just using image integration, I get better results. I've also tried doing the same thing if I'm not going to get RGB data for a target. I most often try to, because I like the accurate colored stars using RGB versus generating colored stars that look decent from the narrowband data. There's a lot of scripts to do that now, and they do a good job. But I still think I try to capture RGB data for at least the stars, if nothing else, but potentially for synthetic luminance also. Oops, went the wrong way here. I like to do a linear fit. Maybe that's an old school thing. And the reason why I do that is I like to see what my color looks like before I combine it. It kind of gives me a preview. Now, I know you can do that with the screen transfer function on Link and stuff. I just think this does a better job of it. I generally use the green master as my reference. But you can also look at your masters, your RGB masters, and pick the one with the highest median value as your reference. For me, it's generally the green. So I generally just use the green all the time. Then I do the channel combination to actually create a color master from the RGB masters. And now we're going to start to introduce some potential areas where we can use AI. So here's where I'm looking to basically correct the background of my masters. So I'm doing that for the color masters, the synthetic luminance, and any narrowband masters I have. So pretty much all the masters, I'm correcting the backgrounds. I primarily use dynamic background extraction in the past. I'm more and more using gradient correction with a lot of careful checking to make sure that the gradient that it is removing has no structure in it, which you can do. But I find it does a better job. Another tool, and once again, this is a shout out to Frank. I know Frank, you had Frank last week at SETI Astro. He showed the auto DBE tool that he's got, which basically sets the points, the background points for you automatically, and then just calls DBE. I played with that a little bit, and I've had mixed results. So I kind of stuck with gradient correction. I know he's a person that's a little bit worried about gradient correction in terms of removing structure, but like I said, I'm very careful. I do a number of iterations with this tool to find the correct one that really does the best job. I prefer to just take the time to do that using that tool. So that's basically what I use now. But if you want to use an AI tool, you can use GrAxpert at this point. I played with GrAxpert. Sometimes it does a good job. Sometimes it doesn't. It tends to sometimes, you got to be careful with it because it sometimes does remove structure from your images. So it's like a black box. So you don't really have a lot of control on that structure that it's removing. So just, be careful. It gives you the ability to look at what it's removing. So you got to absolutely look at that every single time, like I do with all the gradient removal tools. Then I'd like to do spectrophotometric color calibration on the color master. If WBPP didn't do the image solving for you, you got to do that. Obviously, you got to use the image solver script on that master before you use this tool in order to get the world coordinates in there so that this tool will work. So I just do that obviously on the color master sub. And now is when I start introducing some of the AI tools here. So I like to run Blur Exterminator first on all the masters. That's what Russ Croman recommended. Starting out with Blur Exterminator, you'll get the best results. Then I use Noise Exterminator. Once again, you have AI tool options here. You can use GrAxpert or Deep SNR for your noise reduction. And I run, once again, noise reduction on all the masters at this point. And here's where, what I used to do has changed a little bit from this point on, okay? Because now using Star Exterminator or StarNet++, if you're not using PixInsight, or if you just don't want to pay for a Star Exterminator, here's where I like to unscreen my stars from my DSO for the luminance and the color masters. So in other words, for the luminance and the color masters, I'm saving both the DSO and the stars as separate images. And for the narrowband masters, I just don't save the stars. So I uncheck the box on Star Exterminator. I don't save those star masters at all. That's unless, of course, I decide that I'm not going to get any RGB data, so I can get some RGB stars. And I want to basically use one of those scripts that will, basically give you approximately decent color stars from your narrowband stars. That's an option that you have. Now's a good time to really correct any background artifacts in the you know, basically your DSO only masters. Okay, so if you do have any background artifacts, now is a great time to actually correct them. It could be even something as simple as, you know, you have a nasty satellite trail that you just can't get rid of, even though you've tried to play with the, you know, the Sigma settings on the image integrations, or whatever, you know, or even just drop those frames that have the, you know, those star trails in them. I should say the satellite trails in them. But you can get rid of them at this point. And using things like the clone stamping tool for the background, and even Blemish Blaster is something that will actually work within the DSO itself to some degree. An example of that, this is a very good, horrible example of some of the background artifacts I used to get when I would image something near a bright star that's off axis. You know, you can see these bright rings that were located on the edge, on the corners here of this image. And using either one of these tools is, it's a very easy time without the stars in the field to actually correct that background before you recombine everything again. So here's where, you know, obviously some of you are probably going to say, is he crazy? You know, he's actually doing all this separate stretching. And honestly, I find it doesn't take long to do it all, and it gets me far better results. So I do, all my stretching is very different depending on the type of image, and it's all covered here. So I like to use GHS once again, but once again, I'll give a call out to statistical stretch. I find as a very simple one-stop shop tool that actually works half decent, but I think I get better results with GHS. So I like to stretch the luminance in the narrowband DSO only, so without the stars in it, the DSO only masters to maximize the detail. You know, in the case of GHS, I may do 5, 6 stretches in order to get some of that dimmest stuff without, you know, blowing out the brighter stuff. In the case of the color DSO, I'm stretching really to maximize the color in the image before I combine everything again. In the case of the luminance stars only master, I like to stretch to the point where I like my star sizes and the amount of stars that are in that image. Once I'm done stretching, if for some reason that it's in a really, really busy field and the stretching alone didn't do it, I may play around with, you know, maybe MLT or something like that on the smaller star layers to get rid of maybe some of those smaller stars. And you can do that when you're only working with a stars only image. And in the case of the color stars only image, I'm basically once again stretching to the point of liking the way the stars look, but primarily the color. You know, I like to use mode color on GHS, and I play with the blending functionality on that tool so that I control the amount of saturation in the stars. But once again, I like to oversaturate a little bit, because once you introduce the luminance back in again, you're going to lose some of that and some of that color. So that's basically what I do. From here, I'm basically now doing my sharpening on the luminance and narrowband DSO only masters. You can see I don't do any sharpening whatsoever in any of the other stuff. No need for it. I definitely don't want to sharpen my stars at all. And there's no real reason to sharpen the color DSO only master, because your luminance is really, and your narrowband stuff is really the framework, you know, for the detail in your picture. Personally, I like to use LHE for, you know, bringing out some of the larger structures, and MLT for bringing out for some of the smaller features in the image. And it's really easy to do when you don't have the stars in the picture and you're not worrying about masking or any of that stuff. Now it's time to start recombining stuff. So I want to recombine my color DSO only image with my star subs. I'd like to use a script called Screen Stars that Mike Cranfield wrote. I mean, you can do it easy enough with Pixel Math, but what I like about that tool, and it's using Pixel Math in the background, what I like about it is it gives you a preview of what your combined image is going to look like. So if you're not liking what, you know, maybe you got too many stars or the color's not right or whatever, you can go back and redo some of the stretching or some of the sharpening or whatever. So I just like to, before I actually generate the image, I like to use the screen star script. Gives me a nice preview of what I'm going to get when I actually generate the image. And the same is true. I use the same script for combining the luminance DSO and the star subs there also. So if the color image now that's got, the DSO and the colored stars back together again, if it needs any more saturation, which frankly, almost rarely, if ever, does it ever need, this is when I would do it at this point before I move on. And now it's time to actually do, start bringing, all these separate frames back together again. So obviously to bring the luminance back with the color master, I uncheck the RGB on this tool. I'm sure a lot of people do the same exact thing, and just use my luminance master in there. And basically I make a copy of my color master sub because I like to keep a lot of history, on everything. So I make a copy of the color master sub. I name that the name of whatever the target that I'm going to be doing, because now I'm getting close to the end. And I basically try different iterations, playing with both the lightness and the saturation sliders on this tool. I generally start with 0.45 for the saturation and 0.55 for the lightness, but I will play with that. I'll do multiple iterations until I'm happy with the results I get. Finally, if I want to bring in narrowband data into the LRGB master that I just created above, I love the NB Color Mapper script from Cosmic Photons, which once again is Mike Cranfield wrote that tool in combination with Adam Block. And this gives you the ability with a lot of control as to what exact color you want to assign to your narrowband as you're blending it into your color image. So in reality, before I actually do this step, now I should have put that in as a separate step here. Of late, I have been using SETI Astro's script for continuum subtraction on the narrowband images, so that I'm just really leaving behind, I'm not including any of the, the reds, the greens, or whatever from, the color images in there. It's just getting the pure hydrogen alpha or whatever, and it seems to give you a much more contrasty image to blend in, with your color image. So, and last but not least, any final processing that's going to be unique to every image, whatever it might be. But up to this point, everything that I do is pretty much a standard workflow. So as a recap, for the overall improvements that I find I've obtained using this particular workflow, which I've been doing now for, I don't know, maybe a year and a half or so, I'm finding that I'm getting better resolution and image detail as a result of utilizing the full possible theoretical resolution of my optical system, using MTF recommendations, making sure you got great collimation, in addition to Blur Exterminator to really deconvolve and get, factor in, or factor out, should I say, the scene conditions. I get better star shapes over the whole field of view, also due to Blur Exterminator. And not only, I like the fact that the stars are not as bloated, they're minimized a little bit, because I don't like, the star fields to overwhelm the DSO that you're shooting. Noise reduction of both the color and mono images without blurring details in my DSO using Noise Exterminator. But once again, Graxbird and Deep SNR are alternatives to that. And as a result of the ability to process my DSO separate from the stars, using Star Exterminator, or once again, you can use StarNet++, I find I have the following improvements. I have more detail in my dim DSO features without overstretching my stars. Stars have more color because I'm stretching them differently. I get better control of my star size and the amount of stars in the image without needing to use star reduction tools, which generally leave artifacts. And I just find it's easier to repair artifacts because now you have basically a background with your DSO that you can easily correct. without having the stars in the way. Even though you could mask them, you know, inevitably you would kind of mess them up. And then, of course, it's much easier image processing without the need of that trial and error iteration that you used to have to do for both deconvolution and noise removable, you know, processes. I don't know about you, but for deconvolution and for all the various tools that PI gave us for noise removal, I was doing a lot of iterations to try to preserve one thing and get rid of another. And in the case of deconvolution, it was just really getting rid of the artifacts and getting the results of the deconvolution that you were looking for, right? So it just makes my life so much easier. Now, in the case of one-shot color, instead of creating a synthetic luminance, you can always extract your luminance. And your question might be, why would you do that? I don't know about you, and I've tried it both ways. I've worked with friends and some my own color data when I had a color camera. Personally, I find that working with luminance data is much easier to work with for finding, you know, for working out the details in the image, the really fine details in the image. I think color distracts your eyes a little bit. And I think working with the luminance, which is really the infrastructure for your image, you can actually see what you're doing better when you're stretching, when you're sharpening, all of that. So that's just me. That's my opinion. And if you do extract the luminance, then really you can follow a lot of the workflow the exact same way that I'm doing it. There's really no need to do a linear fit unless you really desire to do that. I don't see the need for that. You can extract the channels, of course, but honestly, I don't see the, you know, if you really want to copy my workflow exactly, you can do that, extract the RGB channels and do that, but I don't see a need for that, generally speaking. So obviously there's no need for a channel combination in the workflow if you're not doing, you know, a linear fit. Don't worry about it. Other than that, the rest of the workflow would really be the same for one-shot color cameras. So before I move on, are there any questions? I'm just going to show you a few pictures, and I'm going to be pretty much done anyway. So,
Okay,
Kevin,
great.
I have I don't see any questions online, but I have a couple of questions.
sure.
So, assuming that you're primarily adding back HO narrowband data,
Mm-hmm.
not exclusively, but let's say that's what you're doing. What colors do you assign them?
You can assign them any colors you want. I generally assign, obviously, the HA. I've actually looked up what the actual color code is for HA. In terms of hex, that would be the ideal HA color, and I saturate the hell out of it. But you can use any color you want. That's the beauty of that tool, Eric. You can play with colors and play with a color palette to see whatever it is that you like. I mean, for example, I've used recently the 4X script a lot that Paul Astro's done. I really like some of those color palettes that come out of that. You can do stuff like that, you know, with that script. And so I think it's very cool. But generally speaking, if you want, you can obviously assign the colors that are actually being delivered by those narrowband images if you want. You can certainly do that. You know, obviously the blue-green for O3 and you know, for sulfur 2 and obviously HA, you're going to be in the reds anyways, right? So, but honestly, you know, I would play with color schemes because the beauty of that tool is the really cool thing about that tool. And I know Adam did a whole video on it, is that you can play with different colors. I mean, you have the full color palette to play with. And I played with the colors on that, and you get some really interesting results out of it. So,
Well, I actually asked the question because I have a purpose.
okay.
So the hydrogen alpha, you're really detecting the presence of hydrogen,
Mm-hmm.
even though you use hydrogen alpha filter, but there is a reasonable amount of hydrogen beta, which is blue.
Mm-hmm.
So I have a different approach where I mix the blue, some of the blue with the red
Mm-hmm.
to try to reflect the presence of the hydrogen period, not just the hydrogen alpha emission that the
Right.
filter is detecting, because there should
Right.
be no difference between the emission of hydrogen beta. Well, actually there is, but it is significance up to maybe 30%
Mm-hmm.
of the emissions if you have hydrogen, depending on the excitation.
Right.
And with oxygen, it's blue-green, so it's a mixture.
Right. And you
It's
can
not
actually
just
do
moving.
that with that tool. I don't know. Have you played with that? The NB color script?
I do it in Photoshop.
Oh, you do it in Photoshop. Okay.
Yeah.
Well, I'm saying you can actually do that kind of thing in that tool because it has almost the equivalent of layering like you do in Photoshop. Very familiar with Photoshop myself. And you have, it obviously works. The user interface is very much different than Photoshop, but it gives you a similar capability. And in the end, what it's doing is it's creating, it's using a UI to create, a fairly complex pixel map equation in the background, right? I mean, obviously that's what most of these scripts are doing, but you have the ability of doing exactly what you're talking about, and it's an interesting discussion to make. Sure, I absolutely agree with you. You could absolutely do that, and
Well, I was thinking we always have this discussion, what is it really going to look like if you were standing next to it? And the answer is you couldn't see anything because your eyes aren't sensitive.
right.
But if you could, that's the color you're trying to get at when you
Sure.
add back in this narrowband data.
Sure.
That's my comment. Do we have any questions?
Yeah, I've got a
Alex?
question. The last step after you've done everything in your workflow there, you
Mhm.
said you do the things you do to any image, or at least that's what I caught in my brain. I'm guessing you crop it, you save it as a JPEG. What is that? The things you're talking about?
Oh,
Or
yeah.
was there more?
No. It could be cropping. It could be you want to do another S curve because you're not satisfied with the amount of contrast you're seeing in your image between the background and the DSO, whatever it is.
Okay.
That's exactly. I mean, it's not what I'm trying to get at. It's not something common to every image. It's something unique that you need to do to this particular image in order to get what you're looking for out of it.
You're trying to emphasize something that should be emphasized, but you've never seen it emphasized before, and so you're going to bring that part out, that kind of thing.
Exactly. It could be color balance, Alex. Maybe you want to work the blues a little bit more, on a reflection nebula. So you may be masking with doing a color mask on your image to bring out a certain color, whatever it might be.
Okay.
Hey,
do you have any recent work to show us?
Yeah, and that's what I'm going to show you right now. So this is a Tulip Nebula around the Sedona region, something relatively recent that I did. This is a two-panel mosaic, M81 and M82. This is my first two-panel mosaic that I ever did. It came out pretty good. I was happy with it. Below are the actual images that were taken to create the mosaic. Flaming Star Nebula. This was a fun one because obviously there's a fairly large dynamic range to this guy. So you're trying to get the real brights without blowing anything out, and a lot of the dim stuff in the background. M13. I love this image only because you can resolve to the core, but there's so many galaxies all around in this image. If you really kind of blew it up a little bit, you can see a lot of galaxies in here. Needle Galaxy. This is another one that's got a lot of galaxies in the background. And I really love this little spiral up on the top left corner of the image where you can see the nice spiral structure in there. And Cocoon Nebula. Trying to work the dust in this image was a lot of fun, and get some of this reflection nebula here. But and this is actually the Seahorse Nebula, B150, Bernard 150, was a fun one because I've never actually shot a dark dust nebula before, so it was kind of fun to process this in such a way as to I wanted to actually keep a lot of the stars in the background, because obviously this is a very concentrated, you're looking towards the center of the galaxy in a way in this kind of region here. And I wanted to keep the colorful stars in this image, but also, have it, the dark dust get silhouetted, with those bright stars in the background. So it was kind of a fun topic to use. And by the way, if anybody wants to look at any of my other pictures, I'm on Astrobin. I think Molly's put this URL in the description of the video also, so you can check that out. And that's pretty much it. If you have any more questions, I'll be happy to answer them. Otherwise, I'm pretty much done.
Kevin, John asked, could you comment on the pluses and minuses of your RC?
Okay, so the biggest minuses on my RC would probably be, it's not, with the secondary obstruction the size it is, I would not use it for doing planetary work. Other than that, I absolutely love it. It's got a very flat field. Now, I had to do some minor modifications to it to control some of the reflections. So I had the flock. I had to actually pull out the baffle and put in, an extender on it because the GSO RCs are noted to being slightly, the baffle's slightly under length. It's not quite long enough, and it needs to be tapered at the top. So I actually purchased a baffle extender from a gentleman that actually created them using a 3D printer. It does a great job for it. And it was all ray traced by somebody that actually ray traced the light path, from the primary to secondary down into the baffle to make sure that, none of the light was being blocked. But anyways, I pulled that baffle out. I added the extension. I actually put a really flat, painted it inside with a really super flat, ultra flat paint. I actually flocked the inside of my focuser to really make sure that I was getting absolutely zero reflections on my moonlight focuser on the inside on the draw tube. But other than that, I find that the RC does an incredible job of keeping the field flat. Once I got it collimated correctly, my stars were really, really nice shaped right to the edge. So in terms of the positives, I'd say the positives are the flat field, and I love the fans. So it removes any worries of having to do active dew heating. I've never had any issues whatsoever with the primaries getting dewed up with the fans that they've got going on in there. In terms of the negatives, I would say that you can't really use it for a planetary because I think the secondary obstruction is too large for that secondary.
Kevin, you
Yep.
can stop sharing if you want. So
Okay.
we can see more of you.
Sure. All right. So just got to go back here and click on stop sharing. There we go. And you do have, if you're going to get one of those GSO RCs, I'm sure it's probably not the problem in some of the others, but GSO makes almost all the rebranded RCs out there that I know of. You do really need to get that baffle extender, so, which is what I did. And it really removed all my issues. Now I have no more reflections. And that's pretty much it. Any other questions?
There's no more on YouTube.
No,
Okay.
there's no more. Any questions in the room? No.
All right. Well,
Well,
thank you guys.
Thank you for a great and highly organized presentation.
Oh, thank you.
Yeah.
That
It's
used to be
nice
my
to-
business. I used to do a lot of public speaking, so I do know how to use Photoshop.
Photoshop has some AI functions now, which I'm starting to use. So even though I think the mindset of most astrophotographers is PixInsight, I'm not going to see anything else. Please don't show it to me. But Photoshop, after 30 years of Photoshop, there's a lot to be said for it, especially with some of the, well, in addition to some of the new AI features.
Awesome tool. I agree with you,
Yep.
Eric, 100%. I was, honestly, I used it up until recently, until maybe 2.5 years ago. So
And you don't need pixel math.
you don't need pixel math, right? Stick with it, Eric. Stick with it.
No, I'm agnostic. I mean, these are tools, not rules. Right. So PixInsight function, Photoshop function. Are we all set? No more questions. Again, Kevin, thanks very much. And to everyone out there, thanks for hanging in there. You had a nice audience and they stayed with you to just about the entire thing.
Oh, good.
And next week, we have another great presentation, so please show up there. And we've actually filled our calendar, but are always interested in more people that have unique things to say, like Kevin. So
Okay.
other than
Well,
that, I
have a
would
good
say
day. Okay. I do a
who's
lot
ever
of,
running it,
okay.
let's give a little wave.
Good night.
Hi. Oh, hey, Jamie, good job. Jaime, good job
Jaime.
tonight.
Yeah.
Yeah, you
Good
were
job.
bouncing all over the place.
Thanks, Jaime. Yes, take us out, please. Whoops. Oh, we didn't invite Kevin to stay.
We need to make like a list of items so that we can